Hi there, welcome back. Welcome back to the Grundig Satellit 3400, and I'm going to carry on today with the alignment. Before I do, I want to thank everybody who commented on the previous video, the start of the alignment, the 460 kilohertz alignment. I was actually sort of expecting a few comments, and I got them regarding whether I was doing things right or wrong. There were a couple of things that were pointed out to me, and I just want to mention them now. One of them has to do with my initial step of aligning just with a 460 kilohertz carrier. The instructions clearly mention the wobulator. So when they talk about those first three filters, they are definitely talking about adjusting for a curve and not for a peak. That was the first mistake. I did sort of correct it later, but that was the first mistake. You should actually just read the instructions and try and decipher what it is they want you to do. They want you to play with the sweep all the way through, except where they say signal generator. Okay, that's the first thing. The second thing is the time that I swept the sweep for. I put it on 28 milliseconds and 14 milliseconds, and something was pointed out to me that these filters do have a reaction time. And it appeared that some ringing was actually happening on some of these filters. Stefan pointed it out to me as well, that perhaps I should make the sweep slower. And I can do that because this is a digital oscilloscope, so it does hold on to it. It does make it more difficult to actually do the alignment, because if the sweep is, well, let's say I made it 1 second or 1.4 seconds to keep those gradicules, the vertical gradicules at 100 milliseconds per division. Every time I adjust it, I only see the effect sort of a second later. So that's the first thing. But I did try to redo it that way, just to check whether I had any changes to adjust to. It seems that not much was needed. I did, as I said, I redid the whole thing after reading the comments, just to make sure that I had this thing as well aligned as possible before I continued with this stage. Which is the 2.46 megahertz oscillator and the 2 megahertz IF alignment, because that also is part of the IF alignment chain. And that's what we're going to do next. I have tried to follow some of the instructions. I'm talking after the fact. I think what I did here was I did it on 28 milliseconds as well. After reading the comments on this video that went out yesterday, I went and I did a recheck, and it seems to be okay. So I'll leave you to it. Let me show you what happened, and at the end we'll just do a quick test. Not that it's, well, we don't really have much relative data to compare to, but I just want to make sure this thing's operating as well or better than it was before. Enjoy the video. We're going to continue with the alignment, and we are still on this board. We ended up with the alignment of that IF transformer over there. And now we're going on to something completely different. We're actually onto the board that handles the frequencies that are selected by, or the bands that are selected by the turret tuner or the turret selector. And those are handled down here. Now there are two steps basically. One of them is the 2.46 megahertz oscillator, which I mentioned earlier. What that does is it produces a 2.46 megahertz signal, which mixes with the IF coming along here, which is a 2 megahertz with the audio superimposed on that. So then you need 2.46 to get the difference of 460. Now, if we look at where this thing is injecting, it's injecting at exactly the same place where we tried where we did the last alignment. We're injecting in here. Now the difference is interesting because the instructions don't really tell you what you're supposed to do. You're supposed to know what you're supposed to do. But if we think about it logically, it does make sense. What you want to do is you want to feed a signal in here, but this time you're not going to feed 460 kilohertz. You're going to feed a 2 megahertz signal. And they do tell us to measure at the output meter, so they're actually telling us to measure at the audio output. So if we feed a signal in here at 2 megahertz with an audio tone modulated on it, and it meets this mixer, then whatever frequency you adjust this mixer to, it will either allow the 460 to go through or not. In other words, you have to adjust this mixer so that this signal coming in here mixes and gets through at a difference of 460. And if you have a tone superimposed on that, then if you look at the output, the actual speaker audio output, you will be able to see the tone on your scope, or you can hear it, and you can adjust for amplitude by adjusting the frequency of this oscillator here. And there are two places to adjust. The first one is up here. That's the actual coil that you adjust. And the other one is a trimmer capacitor down here, which is sort of for fine tuning. So there's only there's only really one adjustment. This one is a fine tuning. They tell you to set it in the middle so you get more range. Set that at the max, and then you adjust the fine tuning down there. So we'll be doing that. When we finish that, then we go on one step back, and you've got two tuning slugs here. And this is actually the 2 MHz IF frequency, but we'll get to that in a minute. This should be familiar by now. We're looking at this section over here with actually the first part is within that metal enclosure. It's a shield, which we saw on the board. And we can see right away we've got a couple of, or 3 tuning slugs here, or tuning points. We've done that one in the previous video. And now we are looking at this guy over here. This is the actual oscillator, and you want to adjust it to give you 2.46 megahertz. And the best way to do that is you've got a tank circuit, as usual. Here's an inductor, a couple of fixed caps, and a tuning cap. This tuning cap actually is, you want very little effect of it. So they put it isolated with another capacitor, which, because of the way you add series capacitances, it actually reduces the range of this one. But what they tell us to do, let's have a look at the instructions. Here we go. 2.46 megahertz oscillator, alignment sequence, 2.46 megahertz oscillator. Signal generator coupled to MP202. Now, watch this. They say signal generator. They do not say wobulator. That's interesting. I kind of figured what they wanted us to do, but I realized they did differentiate between the two. This is actually a signal generator coupled to measuring point 202, which is the same one we had up here. And the alignment indication is an output meter as opposed to a loose probe. Okay. So what they're telling us to do is to actually inject a signal at point 202. And it's going to be something that the signal generator produces as opposed to the wobulator. We're not looking at a curve now. It's going to be a carrier that has an audio signal modulated on it, or being modulated by an audio signal. Remember that signal that's supposed to be less than 1 kilohertz. And the indication is an output meter, which is usually an AC voltmeter that you put across the output, across the speaker terminals, and you can detect the amplitude of that audio that's coming through. You know, the 1 kilohertz signal that comes through. And they tell us to align 2 points, 8 and 7, and then back to 8. First thing they tell us to, on 8, visually to center capacitor 259. Now what are they trying to tell us? Let's have a look. Here's capacitor 259, and they tell us to visually center. In other words, put the core at the center. The only reason I can imagine is so that you have as much range up and down as possible. Okay, so that's not really an alignment, that's just preparing for an alignment. So once you've visually centered capacitor 259, then you adjust 7.7 for maximum. So then you adjust this guy here, 7, which is the core, for a maximum output. In other words, you are going to adjust it so that you see the maximum deflection on the speaker. And what that's doing is it's taking a 2 megahertz, which you are injecting in here. Remember, MP202? 2 megahertz with a 1 kilohertz or 600 hertz sine wave modulated on it, 30% modulation, for example. And that goes through, and provided this thing is producing a correct frequency, provided this guy is producing 2.46 megahertz as exactly as possible, then this out here, you'll get a 460 kilohertz carrier with the audio tone on it. And because from here forward, it's optimized for 460 kilohertz, right? If this sees 460 kilohertz, that's what you'll see coming through. If this is 2.48, right? That thing there won't be 460. So it'll be reduced, it'll be attenuated, okay? Because it's sort of on the edge of the curve that we wanted to produce. So it'll be lower. Therefore, when you adjust this to exactly 2.46, because that one is 2, you get 0.46 coming through with the tone on it. You can see it at the output, and you know this thing is perfect. And the way to do that is you adjust it with that till you get a maximum. And because this is a little bit wide, you know, the range is quite wide, you can then go here and you go to fine tuning and you adjust it to a peak, to the best possible amplitude out there. So you know this thing is as close to 2.46 as is humanly possible. So let's go look at the board and see where we're adjusting. Here we are again. So MP202, that's where you inject, same place as before. And you're adjusting, there's capacitor 259, so you put that more or less in the middle, not too important. You just put it more or less in the middle. Remember, it's just going to be a fine tuning. Then you go up to this guy up here, which is 7, and that one you adjust for the peak, right? That's the inductor. And this is the one that was filled in with something that looked like resin, but I managed to slowly, carefully scoop out that resin. It wasn't really resin, it was just very dry wax. And the way I did it was with a very small drill bit on my fingers, not on a drill. And I slowly started rotating it. And as you rotate it, the wax is getting caught and you can see it sort of, you know, come out in a thread. And at some point then I realized I could see the actual lug. So we're ready for that. Let's get going. Signal generator is set to a 2 megahertz signal with, again, the lowest amplitude possible. I'm not sure if that's enough. We'll find out soon enough. Then the modulation is type is AM, depth 30%, AM frequency 1 kilohertz. You can make that any tone that is audible. And we're good to go. So we've got that coming out of the signal generator. It again comes into the switched pi attenuator. I have some attenuation here. I don't know how much I will need, if any. I've got the signal coming out of that, and it's going into measuring point 202, just as before. I have now connected the external speaker to here. That is connected to the audio dummy load selector in here. I've got dummy at the moment, but I'm going to put it on speaker so we can hear it at the start. I've also got connected to it a voltmeter, AC voltmeter, which is this guy here. I'm putting it on AC volts. I don't know exactly what range, so I'll put it on the 1 volt range. This just makes it easy to adjust for maximum. So you can see the deflection of the meter as opposed to watching the amplitude on the scope, which is a little bit difficult. I think we're ready to start. Switch on the radio. We can certainly hear it. You can see it on the scope there. We can see it on the meter. It's a very small deflection, so I'm putting it to 0.3 volts, maybe even 0.1. Okay, I'm going to flick this to dummy load so we don't have to listen to that. And now we will adjust. I'm going to put this guy in the center here. I think it's the center, not quite sure. And now I can adjust this guy. Whoa, we have overload. I'm going to increase the attenuation and a bit more. It's still a bit high. I'm going to put in 24 dB and 27 dB. Okay. I'm flicking something here. What am I doing? We're still hearing it. Yeah, we can still hear it. Okay. So now I'm going to see if I can peak it. Whoa. See, that is very sensitive there. That's about a peak. But I'm glad I've got the trimmer, because that thing was really, really moving all over the place. Oh, sherbet. So is this one. Now this is a bit better. That seems to be a peak. Oh, that that was easier than I thought. We've done it. Okay, good. Let's see what we've done and what we need to do next. Guess what I'm going to do? Done. 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 And done. Brilliant. Onwards. Right, point C, AM alignment of the IF for 2 megahertz. What are they telling us to do here? Okay, we're back to wobulator. We're back to wobulator, so they want a curve, okay? Wobulator output connected via isolating capacitor to MP201. Where are we? Where are we? Where are we? Ah, okay, here we go. Over here. So you connect your wobulator, your signal generator in our case, to measuring point 201 through an isolating capacitor. In other words, you want to AC couple it. And our attenuator, that pi attenuator is AC coupled anyway, so I can connect it directly to there. Then it comes in here, and I presume you've got to adjust that, that, and that, right? So we've got 9, 10, and 11. Let's check. I have filter 11, but this thing is messed up. They give the filter numbers in Roman numerals, and at this point in the alignment, we're on filter 11, and we're adjusting, you know, adjustment point or adjustment step 10 and 11 and 9. It's actually 11. Okay, so we can't confuse the two. So I have filter 11, which is adjustment point 10, and you inject in there, and you indicator is on MP202. Okay, MP202 is where we were before. So we are injecting in here, and we are measuring over here. Okay, makes sense so far. Then at an input of 50 millivolts, adjust 10 for a minimum dip. So you inject 50 millivolts in there. That's pretty high. I mean, we've been working with sort of 1.4s and things like that. Okay, but you are measuring here. You're not measuring at the output. So for 50 millivolts in here, you are measuring here, and you adjust 10 for a minimum dip. So this one here for a minimum dip. What the hell do they mean by a minimum dip? Well, I suppose we're going to have to connect it and see. But what I'm going to do, I'm going to sweep it again. And I'm going to set the sweep center frequency at 2 megahertz. And I'm going to sweep like, 20 kilohertz or 30 kilohertz below and 20 or 30 above. And we'll see what comes out here. And then we'll see what happens when we adjust 10. I'm not really sure. But let's see where these things are. 10. Okay, here's 10. That's the one we're going to adjust first. There's MP201. Where is it? There. Okay, so the injection point is right next to that IF transformer, and we adjust that one, and we want to see a minimum dip over here. Well, I'm going to set it up and see what we see, because I don't know what we're expected to see. That's part of the fun. Let's set this thing up. I have this on 2 megs, 1.4. I'm going to put 50 millivolts on here to make sure no attenuation is on. And I need to do a sweep. It's a linear sweep. I'm going to start at... Oh, something I realize now after using this so many times. I remember that you can do this center and a span. So I'm going to do the center at 2 megahertz and the span of, say, 30 kilohertz. And the time I'll leave it at 28 milliseconds for the reasons I've explained before. When this thing starts, it's sending an output from the trigger output at the back, which I'm injecting into or detecting on channel 2 of the scope. There it is going in here. It's coming from the back of the scope, trigger out, going to channel 2. I've got channel 2 selected, and that's my square wave. Start and end of each sweep. All right, and then I trigger the scope on channel 2. I've got to make sure it's triggering on channel 2. And then when I do this at 2 milliseconds per division, that span is taking 28 milliseconds, which is what my signal is. So now all I need to do is I'm going to look at signal on 1. I don't know what to expect here at all. So I will see. Everything is set. Let's see what happens. Oh. Oh. Okay. That is a curve. That is a curve. Okay. That's a curve pretty similar to what we saw with the other IF alignment, especially if I do that. No, it's too high. Okay. Well, without changing anything, let me adjust 10 and see what happens. Oh. Oh. It's going up. Okay. I've just adjusted 10. That's 50 millivolts coming in. I'm going to change the span here to 14 kilohertz. Okay, that's more like what we want to see. 14 kilohertz, so that's 7. So each one of these is 1 kilohertz. Let's see if I can. And it's right in the middle, which is what we want. But it's telling us for a minimum curve. In other words, I think, or minimum dip. So I think they're talking about that dip there. So I'm going to go again. It's actually moving the other way. I think that there is sort of minimum dip while still keeping this centered. Again, easier than I thought. Let's see what else they want us to do. So we seem to have got that minimum dip over there. Now they tell us filter 12, which is, that was 10. Now filter 12, which is adjustment point 9 for a maximum. So that was 10. So 9, which is this one, for a maximum. And where is 9? That was 10. This is 9. So it's that IF transform at the bottom for a maximum. And then C214. At 500 millivolts input, the IF curve must be adjusted with 11, which is, I presume, C214, without raising the base of the curve for maximum steepness. Do I pretend to know what I'm doing here? Okay, there's 11. So we are going to inject, leave it injected as it is. We're going to adjust this guy. And then this guy is for maximum, and then this one is for 500 millivolts. They're talking about 500 millivolts input. The IF curve must be adjusted with this capacitor without raising the base of the curve for maximum steepness. Well, I'm going to go and do that one at the bottom there for maximum. I'm not even going to show you. It's pretty obvious. Let's see what happens when I... Okay, so this does roll the curve a bit, which means that's a maximum there. But if I go back to this one and this is the previous one. Remember, it was flattening out a bit, but it was rolling over. I'm doing the two together. Previous and this one. Sort of, see, that rolls over. I want it there. Going back to the previous one to see if I can't minimize the dip to make the pass band as flat as possible. No. That's definitely the minimum dip. And back to where we're supposed to be, and that's definitely a maximum. That's done. That is done. Okay. Now this part leaves me a little bit nervous because what it's telling us to do is to increase this by tenfold, 500 millivolts. Jeez. Well, I've just checked the German version of the instructions and it definitely says 500 millivolts. So I'm going to make that a lot smaller. Make sure this thing is well grounded. Let's try 100 millivolts. Well, 200, 300, 400, 500. Nothing's exploded. It's sort of gone wonky here. Okay. It really has gone wonky, I think. I'm just going to do it from here, and I'm going to try and see what happens when I adjust that capacitor. I have no idea. Oh, beauty. I'm just twiggling this thing and it's getting really steep. Why am I surprised? That's what they tell us it's going to do. I'm just surprised I can do it. That is a turning point, sort of going, I'm rocking backwards and forwards. Hope you can see that. That's where it's steepest. Oh, I've got this on 600. Whoopsie. Whoops. Let's set that again. Well, that looks as steep as it's going to get. And now if I go back to 50 millivolts and I play with this, it's back to 50. I'm going to see if I can adjust those other two again. Never happy. I want to see where the center is. It's right in the middle there. Yeah, that's good. And this one here for maximum. That, my friends, is as good as it gets. I think we've done it. I think we've aligned the 2 MHz IF. Right. Here we go. We're on medium wave. Again, it's sort of mid-afternoon, so it really is not a good time, but no time like the present. The one thing I've noticed is that the difference between narrowband and broader, not the broadest, but broader, doesn't make that much difference in terms of signal level. It sort of rises a little bit, but not much. That is perfectly clear. That's amazing.
La vida y el fútbol. Y eso de ti viene por eso. Se ha proyectado desde.
Ella, que es la abogada encargada de leer ese testamento del ex marido que fallece en la obra. Cuéntanos cómo es tu personaje.
Okay, that is as expected. Long wave. I'm just wondering if that hasn't changed a little bit, a couple of kilohertz. I'm not sure. Anyway, let's carry on. Let's try shortwave. Let's go down here, where we're going to get something probably around 12 megahertz. Let's go up to the 25 meter band.
Not from reason, nor from instinct, but from sympathy, from the power of sympathy. Now, what is the secret of the power of sympathy of the Chinese people?
A los últimos días de mercado que estas cosas.
Tanzania,
Hay falta sobre Gavi y ojo porque está jugando el Getafe con su capitán en Dene que está
That sounds like medium wave.
al banquillo que ahora sí que quiere el cambio porque no se tiene en pie. Fíjate cómo va el Dene.
This must be from the Canary Islands.
No va a poder seguir, Dene. Pues...
Juliet, Yankee, 5, Hotel X-ray, Thank you very much for your call sign and your call, my friend. You are calling 5 by 5 here in the south of France. Golf Lima Sierra, 6 my phone knockout. Hotel Echo, Romeo, Victor Echo, Henry.
in my log, congratulations, thank you very much. You are coming 5557 here on 2-element beam antenna. The transceiver is an ICOM 7610. Here in the south of France, we have at this time 27.
Well, what else can I say? That's about as clear as I've ever received on the up on the, what is it, the 16 meter band. This is 18.12 megahertz. That is as clear as I've ever received sideband. This is with the BFO active. As you can see, pretty easy to tune in. I am not sure about how accurate that display is. I would expect it's fairly close, but as I said, I've got a feeling, just a feeling, looking at the medium wave figures, that this might have shifted. Well, not this, but the whole tuning might have shifted 1 or 2 kilohertz, but we'll find that out later. I'm not sure if there's a way of adjusting this. I haven't got to that yet. But yeah, I think I think this is done. This part is done. So the AM alignments, the IF and the oscillator for 2.46 are done. I think the result is positive. I'll be listening to this again later tonight when the bands do tend to fill up a little bit more. Again, it's not easy to compare because one day you might have clear reception, the next day you might have atmospheric conditions that make it a little bit more challenging. But the question is, am I happy with it? Yes, I'm absolutely thrilled with it. And what I want to comment about the alignment procedure, it is not that complicated. It's a little bit confusing if you don't know what you're doing. But as the saying goes, I get by with little help from my friends. And talking about my friends, I want to thank you all for watching. Hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. One comment, I'm seeing a lot of views from non-subscribers. So let me get on my knees and beg you, please subscribe. It does help with the way that YouTube presents suggested videos. Do subscribe. If you get really pissed off with me in the future, you can get the satisfaction of unsubscribing. Believe me, it's a great feeling. I've done it before. So anyway, once again, thank you very much. Thanks for watching. Bye for now and stay safe.